Good morning, class. In the last lecture, we have seen the machine learning techniques. Basically, there are the 7 techniques: classification, categorization, clustering, trend analysis, anomaly detection, visualization, and decision making. So these machine learning algorithms are mostly used, and we can categorize these machine learning algorithms in 7 categories. So today we will see one by one the introductory part of this 7 technique. So the first is classification technique. So what do you mean by the classification? The classification is a new observation. Here we can predict the discrete responses and predict the qualitative targets. So in classification, we already have some data, label data, and on the basis of some characteristics or feature, we classify that data. That is called as a classification problem. We are using the discrete responses. So what do the discrete responses mean? Here we are getting the response like the true, false, positive, negative, 1, 0, boy, girl, man, woman, so white, black. So the classification is minimum 2 parts. We are divided into the 2 parts. Okay, but whatever the data we are providing for the classification purpose here are the labeled data. So labeled data means it's already distributed. Okay, they are already labeled. We categorize them, and now based on that we have find out the classification of new observers. So if new images come, for example, let us consider the classification of cat and dog. So in this example, we already have some images, label images, and that images are tagged with the proper label, who is a dog and who is a cat, on the basis of their characteristics, on the basis of their feature. The classification algorithm are classify the image into proper class of dog and the class of cat. And when we give some new image to predict is it dog or cat, using the label data, our classification algorithm is classify that new data, either it is a cat or it is a dog. So this is a basic information about the classification. So you can see that this is a discrete response. The next technique we see that is called as a categorization. So what do you mean by the categorization? A categorization is a technique to organize the data into categories for its most effective and efficient use. So let us consider we have the unlabeled data. Here the data is unlabeled. Okay. There are no labeled data. So we have the mix of data, and on the basis of again some feature, common feature and characteristics, using this categorization technique, we categorize that data into different categories. So you can see on the screen there is some mixed data, and using the categorization we are categorize this data into the 3 parts. So this technique is called as a categorization. But what exactly you can classify, you can differentiate between the classification and the clustering. So if you want to differentiate between the classification and the clustering, then based on some criteria we can differentiate between the classification and the clustering. The first one is prior knowledge of the classes. So in classification, obviously we have the prior knowledge of what kind of class you want to create. Okay, how many classes you want to create from this data set. For example, cat and dog. So you are making the one class for the cat category and you are making the class for the dog category. So there is a predefined classes in classification. So you can say that there is a prior knowledge of the classes. While in clustering, there is no predefined classes. You don't know how many classes you can create from that particular data set. It may be a 2 classes, it may be a 3 classes, it may be a 4 classes, depending on the data. So the first difference you can find out between the classification and clustering is that in a classification you have the prior knowledge, while in a clustering you don't have any prior knowledge. The second criteria is use cases. Classify new sample into the known classes. You have to classify the data set into the known classes. So you already know the classes, that is a cat is a class, dog is a class, boy is a class, girl is a class. So you have to just classify that sample into that particular known classes because you already know how many classes are there. There may be 2 classes, 3 classes or n classes. But you already know that if you predefined, you know that there are the these number of classes, and now the new sample you have to classify according to the characteristics. While in clustering, the suggested group based on the pattern in a data. So what are the pattern you are finding out? So based on the pattern, you have to make a clustering. So there is no known classes in a clustering or known information available in a clustering. Some of the very popular algorithms we can say that used in a classification and decision tree based on a classifier, while for clustering, very popular algorithm is a k-mean clustering, then expectation maximization, etc. While the data we needed for classification is a label sample, while for the clustering we require the unlabeled sample. Okay. So for the classification, keep in mind that if you want to create a classification or if you want to use any classification algorithm, for example, decision tree, Bayesian classifier, so your data must be a labeled data. It's properly labeled, who is a dog and who is a cat. But in a clustering case, you don't have any prior information about the data, so you cannot label that data. But once you implement a clustering algorithm, you will get a data cluster. So this is a basic difference you can say that between the classification and the clustering. Move ahead. Next technique, a very popular technique, that is a clustering. So what do you mean by the clustering here? The clustering is again the collection of the objects that is based on the similarity and the dissimilarity between them. This is again the unsupervised machine learning type, where you have to make a group of objects that they have some similarity and the other objects that don't have their similarity. So this is a collection of objects that is based on the similarity and the dissimilarity between them. Okay, so we can differentiate between the clustering and the classification. So again, in a clustering, unlike the classification, clustering are not predefined. While the classification, the classification classes are predefined. Boy is a class, girl is a class, male is a class, female is a class. So you have the predefined classes. But in a clustering, again, for the same as the categorization, you don't have the predefined classes. The clustering is an unsupervised learning approach, as I already discussed that. It is unsupervised. We will see what is the supervised and unsupervised in the next slide. So clustering is an unsupervised learning approach, while classification is a supervised learning. In a clustering, does not use the label data or training data set. Okay, so here in a clustering you can find out there is no label data. So data is not labeled in this clustering, while in a classification the data is labeled. The algorithms used in a clustering are K-mean clustering, hierarchical clustering are the most popular. Okay, these are the most popular. I am saying that. There are the number of algorithms you can use for the clustering, but these two are very basic, and in our syllabus we will use this. We will learn this K-mean clustering and the hierarchical clustering. While in a classification, very popular algorithms are K-nearest neighbor and decision tree algorithm. And in this syllabus also we are learn these two algorithms and few other classification algorithms. Moving to the complexity, if you ask me the complexity, so which is the complex one? So the clustering is less complex as compared to the classification, while the classification algorithms are more complex. So you can go for the clustering if you don't have the label data, because these are the less complex algorithms. But if you have the label data, so you can use classification algorithms. The next technique is trained analysis. So what is that trained analysis? This trained analysis is basically used in stock market prediction examples. Okay, where the time series algorithms are used. So in this algorithm, in this case, we have used the trained analysis. Here we represent the variation of low frequency in a time series and the high medium frequency of the fluctuation between swing routes. So when you have the data that is a timely you are managing, so that is called as a time series. Okay, and this trained analysis is mostly used in a stock market prediction process. Another technique is very popular, that is called anomaly detection. So from this figure, you can also see that what is the anomaly. So anomaly is nothing but something different from that regular thing. So you can see in the picture that fishes are moving from the right to left, but one of the fish is there moving from left to right. So that is something different. So that is an anomaly. So that point, you can be said that point is called as an anomaly point. Because normally, the movement you are expecting is from the left to right, but some point, there is one packet, it is moved from the left to right. So there must be something going wrong with your network. And using this, you can find out the anomaly in your network. So anomaly detection is called intrusion by indicating the presence of the intent or unintended, include the attack, defense, fault, and so on. So this anomaly in anomaly, you have to just find out irregular activities that happen in your network. The next technique is very popular and most widely used machine learning technique, that is visualization. So what is the visualization? So visualization itself explains that what are the data you have, you can visualize it in proper way. So that is called the data shown in the form of picture, makes it easier to understand. So from the picture itself, from the picture itself, you can form such a picture that you can understand what exactly that data is going to represent. So how many students are failed, how many students are passed, then how many students are in first class, how many students are in second class. Okay, so if you want to make such type of data showing, so you can use the visualization concept in the machine learning. And very popular and the last technique is a decision making. The machine learning is also useful for decision making. Now, what is that decision making? So, somewhere, some point are there is where you want to take some decision. So, based on your previous data, based on your historical data, you want to do this, take some decision. Let's take one example of a famous, that is cricket. So let us consider you are the main captain or the coach, and you want to take a decision that if you win the toss, so you will be elected for bat or batting or bowling. So how you can take that decision? That is because it is most important decision before we start the match. So who will be the responsible for taking this important decision? Either your team member or captain and the main coach. So how they can take a decision that after winning a toss, we will elect the batting, not bowling. For that coach or that captain must have the previous historical information about that particular ground, that pitch, how it is behaved. So is it useful for the spacer or is it useful for the spinner? So if you have the sufficient information about that ground, about a pitch, so on the basis of that information, historical information, I would like to say historical information, you can take a decision that you will be elect that or you will elect the bowling. So for taking such type of decision, we are also use the machine learning. We are implementing our various decision making algorithm on our previous available data, historical data, and we are getting a accurate decision. Not 100%, but we can consider it as accurate data. It may be up to 90 to 99% accurate. Because using the machine learning, I would like to say you cannot get a 100% correct decision. Okay, because this is just a prediction you are giving using the machine learning algorithm. It is not possible for anyone to give the 100% correct prediction using the machine learning. You are giving some accuracy, and you have to improve that accuracy regularly. So for the first time, your algorithm will give the accuracy of 90%, and for using a different algorithm or making a different combination of attribute, features, or increasing the historical data, your accuracy will be the 95%, 97%. But it has the limitation that your machine learning algorithm or your deep learning algorithm will give the accuracy up to the 98 or 99%, not 100%. Okay. Because it is a machine, it is not a God. So this is all about the machine learning techniques. So you have seen that there are the basically 7